I'm here. I made it. Look at them go. Look at them go. They're so cute. I remembered as I was watching through, because I'm trying to like trying to do the streams and then rewatch them to just like retain it, you know, just listen to my damn voice over and over, saying the same shit. But I was wanting to do typing tests before we start reading. I kept forgetting since we came back. So we're gonna start with typing test. Okay. I think I'm like, is it? I remembered like as I started streaming, I was like, oh yeah, I was supposed to do a typing test. So I'm like, is it positioned right? Looks good. Okay. I think I'm just gonna go into it. We're gonna avoid Engine Explorer. All right, I'm gonna look over here so it's bigger and better. Nope, it's not going. Crap. Hang on. Oh my goodness. I have a Maddie hair in my eye. Started a bit late. There's a really rough thunderstorm going on, so Maddie she's conked out, but that's like stress sleeping, like if I'm gonna die, just let it take me kind of. It was like the kind of thunder that like rattled the windows, so she's like really freaked. I was a little freaked. Okay. Gonna void. We're going. And it's like I want to keep doing these so that we can keep track of, as we're working and coding, how much quicker we're getting with typing. Oh, fuck. We're gonna be a bit slow right now because I'm a bit rusty. Clear. Okay, plugin. We know that case is important. I thought the song was done. Okay. Bring it back. Hello? Is that not the hello? Okay. Whoops. I was doing plus. I turned the music up a little bit. Let me know if it's too loud, like if you can't hear me, or if it's great. I just figured there's a lot more like quiet space. Well, actually, you know, I was like, what am I saying? These streams especially, I'm like just talking from reading. I don't know. I was watching it. I was just like, man, I wish the music was a little louder. Yeah, Maddie, pay attention. What the hell? She's too tuckered out. She can't. I can't ask her to. Just let her nap. Recover from the war that was just raged. Raged? Oh my god. Waged. Icon. Engine. Oh my god. I don't know how to type, y'all. This isn't super home row keys. Like I am keeping my index finger on the rage war. It's that damn rage war. Keeping my index fingers on the home row button, like what are they called? The F and the J, you know, but I'm kind of floating, which I think is what you're meant to do, really. supposed to kind of just know where the keys are and float around while staying like anchored to the home row. Yink. 18. I think we got it like to 20 something. It'll get better. I'm gonna be rusty for right now. Yeah. Yeah. All right, I'll leave this up because I do also maybe want to end. See, like, you know, now that we've warmed up with it. Oh my god, I was writing void into the chat. That's what happened. Hello. Okay, we're back here. Yeah, see if after now that we've warmed up, if at the end of the stream we'll maybe be a little bit faster. I'm sure it'll happen more and more. I got quite the high off of those little coding pop quizzes, and so I'm like, oh, please ask us to code more stuff. Like, please, I love it. Let's make a function. Let's do it. Okay, let's go. 2.1 Introduction to Functions. In the last chapter, we defined a function as a collection of statements that execute sequentially. While that is certainly true, that definition doesn't provide much insight into why functions are useful. Let's update our definition. A function is a reusable sequence of statements designed to do a particular job. You already know that every executable program must have a function named main, which is where the program starts execution when it is run. However, as programs start to get longer and longer, putting all the code inside the main function becomes increasingly hard to manage. Functions provide a way for us to split our programs into small, modular chunks that are easier to organize, test, and use. Most programs use many functions. The C++ standard library comes with plenty of already written functions for you to use. However, it is just as common to write your own. Functions that you write yourself are called user-defined functions. Okay. Consider a case that might occur in real life. You're reading a book when you remember you need to make a phone call. You put a bookmark in your book, make the phone call, and when you are done with the phone call, you return to the place you bookmarked and continue your book precisely where you left off. C++ programs can work in the same way and borrow some of the same nomenclature. A program will be executing statements sequentially inside one function when it encounters a function call. Oh, answer the call. Answer that function call, talk to whoever, hang up, and keep running the program in the book. Right? Function call tells the CPU, okay, it's still lightning out. We're just gonna bless the stream that we're all gonna stay here. We're gonna have I guess we do have some drop frames a little bit. I usually see that as 0. But now it's at 3%. I don't know if that's probably nothing. But I'm like, is that the lightning? Did the lightning do that? I need to add the sound commands to my stream deck so I don't have to keep asking y'all. Oh, I love that. All right. Start this paragraph over. I just need to show you real quick. Real quick. This is not real quick. Hello. Alright, this is what I'll do. Look at this stinking guy. He's having like a tea right now. This is his schedule, okay? And I'm having a tea right now. Oh. That's what I hear when I take a sip of Arizona. Sorry, he was just sitting there having his tea, and I was like, oh my god, I'm having my tea. Okay, restart this paragraph. C++ programs can work the same way and borrow some of the same nomenclature. Program will be executing statements sequentially inside one function when it encounters a function call. A function call tells the CPU to interpret the current function and execute another function. The CPU essentially puts a bookmark at the current point of execution, executes the function named in the function call, and then returns to the point it bookmarked and resumes execution. No, I wanted both, actually. And there are a couple of trying to figure out how to do it, but there's a couple of commands I want, like when you play a sound command, it'll put in chat the emotes, but I'm trying to figure out how to get it. It would need to use my account so that it has access to the emotes. But bless is one for sure. That's like, if you use the sound command, I'd like the emotes to show up too, you know. Nomenclature. The function initiating the function call is the caller, and the function being called, executed, is the callee. A function call is sometimes called an invocation, with the caller invoking the callee. Well, right, there was, I don't remember what it is. Oh, it's fine. When you ask if you're fine or you're not fine, I wanted it to do Tanaboat fine, obviously. That with the sound command would be so good. I think actually I could simulate that, right?
They ask you how you are, and you just have to say that you're fine. And you're not really fine, but you just can't get into it because they would never understand.
I love it so much. Okay, an example of a user-defined function. First, let's start with the most basic syntax to define a user-defined function. Isn't this so good? For the next few lessons, all user-defined functions will take the following form. Return type, function name. That's the most basic syntax. So our function name could be like green tea, capital T. So it would be return type, green T, capital T, parentheses. This sounds like an Undertale song a little bit. This is the function header. Or at least that part. Tells the compiler about the existence of a function. This is a function body. Tells the compiler what the function does. Okay. That's where the statements go. This first line is informally called the function header. Informally? What is it formally called? And it tells the compiler about the existence of a function, the function's name, and some other information that we'll cover in future lessons, like the return type. In this lesson, we'll use a return type of int for function main, or void otherwise. For now, don't worry about these, as we'll talk more about return types and return values in the next lesson. Function return values, value returning functions. The music got me. I was like, hello. Just like variables have names, so do user-defined functions. The function name is the name identifier of your user-defined function. The parentheses after the identifier tell the compiler that we're defining a function. The curly braces and statements in between are called the function body. This is where the statements that determine what your function does will go. To call a function, we'll use the function's name, followed by a set of parentheses. Sorry, function doesn't look like a word anymore. I was like, huh? That's how it's spelled? Function name calls the function whose name is function name. Conventionally, the parentheses are placed adjacent to the function name, with no white space in between them. For now, a function must be defined before it could be called. We'll discuss ways to work around this in lesson 2.7. Okay. Gotta define it and then you can call it. Interesting. In lesson 2.7, forward declarations and definitions. Here's a sample program that illustrates a user-defined function being defined and called. For standard character output, definition of user-defined functions doPrint. doPrint is the called function in this example. Void doPrint, character output, in doPrint. Interesting. Int main, character output, starting main, doPrint, so that'll run the function. This is the function. So here, it's gonna just run this one statement. So it's gonna starting main, in doPrint, ending main. This statement is executed after doPrint ends. Interrupt main by making a function call to doPrint. Main is the caller. Main is saying, what is, we need to make a call to doPrint because what's supposed to be here, doPrint? And then doPrint's like, this statement here. Please character output in doPrint. And it'll say, oh, all right, cool. And then it'll keep going. And then it'll end. This program produces the following output. As expected. This program begins execution at the top of function main, and the first line to be executed prints starting main. In the second line in main, a function is called function doPrint. We know it's a function call due to the trailing parentheses. Warning: when calling a function, don't forget the parentheses after a function's name. If you forget the parentheses, your program may not compile, and if it does, the function will not be called. Okay, so it's not going to be a function. Because a function call was made, execution of statements in main is suspended, and execution jumps to the top of called function doPrint. The first and only line in doPrint prints in doPrint. When doPrint terminates, execution returns back to the caller main and continues from the point just beyond the function call. Consequently, the next statement executed in main prints ending main. Calling functions more than once. One useful thing about functions is that they can be called more than once. Here's a program that demonstrates this. So the same thing, but it's just going to say it twice now. Since doPrint gets called twice, doPrint executes twice, and an in doPrint gets printed twice, once for each call. Functions can call functions that call other functions. Ooh. You've already seen that function main can call other functions, such as function doPrint, in the example above. Functions called by main can also call other functions, and those functions can call functions too. In the following program, function main calls function doA, which calls function doB. Okay, we have function doB, doA. With doB, it says in doB. For doA, it says to start with doA, hold doB, and then finish up doA. And then in main, we're going to say, can you just pull doA? And doA is like, yeah, I got stuff from here and from B to give you. This program produces the following output. Starting main, starting doA, in doB, ending doA, ending main. Nested functions are not supported. When I read this, I was like, is that like nested functions? Because I feel like that's like not, those aren't good, right? Nested functions are not supported. A function whose definition is placed inside another function is a nested function. Unlike some other programming languages, in C++, functions cannot be nested. The following program is not legal. I might be wrong. I feel like Java you can. But I remember like it like being messy and frowned upon still or something. I don't know. I might be wrong. I'm probably wrong. Part of me wants to get, not right now, but at some point get my Java book off the shelf and like kind of just have access to it to like kind of relate the differences, I guess, of what I learned in my Java class to what I'm learning here, which I was not learning this in depth. Like, I feel that I'm actually like taking in each topic. Like, I feel like the building blocks are like actually being placed instead of just being like, this is Java, like here. I'm like, I'll try to figure out how this should be written so that I can get the output you're asking me for, and then we'll just move on. It's like I can fake it, you know. Okay. So this is not legal. So we have int main. Oh. Yeah, the function needs to be outside of main. Do your functions and then you start your main. Illegal. This function is nested inside function main. Foo. You foo. Function called to fool. And it's like you're trying to call something you just put in here. It's like you just write the statements. Proper way to write the above program is right above here, no longer inside of main. Write your main, call the function. Nomenclature. Oh, okay. Like, you fool. You fool. Nomenclature. Foo is a meaningless word that is often used as a placeholder name for a function or variable when the name is unimportant to the demonstration of some concept. Such words are called metasyntactic variables. Though in common language, they're often called placeholder names, like lorem ipsum, right? Is that, you know? Since nobody can remember the term. Metasyntactic variable. Other common metasyntactic variables in C++ include bar, baz, and three-letter words that end in oo, such as goo, moo. Sorry. Goo, moo, and boo. For those interested in etymology, how words evolve, RFC 3092 is an interesting read. Okay. Sorry, yeah. Moo. Okay. Noted. Gotcha. In a function definition, what are the curly braces and statements in between called? Function body. I pay attention. I try to. What does the following program print? Do not compile this program. Just trace the code yourself. Just read it. It's like reading sheet music. Okay. Okay, so we have our function do B. We have our function do A, which also calls do B. Definition of function main. So this is going to character output. It's going to first say starting main. Who? And then it's going to say into A, into B, into B. So I'm going to say ABB. Whoop, lightning, sorry. ABB. So starting A, BB, ending. Starting A, B, B, ending. I feel like the building blocks are just like, you know. Let's go. 2.2. All right. Consider the following. Enter an integer. It initializes num, character input num, print the value doubled, so output number doubled is number times 2. This program is composed of 2 conceptual parts. First, we get a value from the user. Then we tell the user what double that value is. Although this program is trivial enough that we don't need to break it into multiple functions. What if we wanted to? Getting an integer value from the user is a well-defined job that we want our program to do, so it would make a good candidate for a function. So let's write a program to do this. So now the function is get value from user. So instead of this being a statement, if we want to call this often to ask the user for an integer, the function is a series of statements of character output, integer, initializes input, character input, input. And then we're going to call the function inside main, get value from user, ask user for input. It initializes number. How do we get the value from get value from user and use it to initialize this variable? It's a good question. Well, okay, we've just initialized num. And use it to initialize this variable. I don't know. Yeah, I'm like, I don't feel that this is putting it in here from this code. Well, this program is a good attempt at a solution, doesn't quite work. Yeah, I was like, what? There's a disconnect. When function get value from user is called, the user is asked to enter an integer as expected, but we need to do another function for the output. I bet. There's gonna call whatever, right? Whatever function input did. It's gonna be like, hey, input, what do you have? Right? No. Hang on. When function get value from user is called, the user is asked to enter an integer as expected, but the value they enter is lost when get value from user terminates and control returns to main. Variable num never gets initialized with the value, and the user variable num never gets initialized with the value the user entered, and so the program always prints the answer 0. What we're missing is some way for get value from user to return the value the user entered back to main, so that main can make some use of that data. Return values. When you write a user-defined function, you get to determine whether your function will return a value back to the caller or not. To return a value back to the caller, 2 things are needed. First, your function has to indicate what type of value will be returned. This is done by setting the function's return type. It did have previously return something, which is the type that is defined before the function's name. In the example above, function getValueFromUser has a return type of void, meaning no value will be returned to the caller. And function main has a return type of int, meaning that a value type of int will be returned to the caller. Note that this doesn't determine what specific value is returned, only determines what type of value will be returned. We explored functions that return void further in the next lesson. Void functions, non-value returning functions. Second, inside the function that will return a value, we use a return statement to indicate the specific value being returned to the caller. The return statement consists of the return keyword, followed by an expression, sometimes called the return expression, ending with a semicolon. When the return statement is executed, the return expression is evaluated to produce a value. The value produced by the return expression is copied back to the caller. This copy is called the return value of the function. The function exits and control returns to the caller. The process of returning a copied value back to the caller is named return by value. Okay. Nomenclature. The return expression produces the value to be returned. The return value is a copy of that value. What? The return expression makes the value that's going to be given to main. The return value is a copy of that value. Right, okay. It was like, this is what I got. A value returning function will return a value each time it's called. Let's take a look at a simple function that returns an integer value and a sample program that calls it. Okay. Kind of wanted to fix the one that we were already working on, but okay. Let's see. Ooh. A return type of int means the function will return some integer value to the caller. Return 5. The return statement provides the value that we returned. It's saying return 5. It's going to give the caller a value of 5. Output return 5. Output return 5 plus 2. 7. Okay. The value 5 is returned, but it's ignored since main doesn't do anything with it. Oh, it's not outputting it. It's just it's pulling 5, but it's like, what do you want me to do with that 5? When run, this program prints 5 and 7. Execution starts at the top of main. In the first statement, the function call to return 5 is evaluated, which results in function return 5 being called. The return expression 5 is evaluated to produce the value 5, which is returned back to the caller and printed to the console via character output. Excuse me, I'm burping. In the second function call, the function call to return 5 is evaluated, which results in function return 5 being called again. Function return 5 returns the value of 5 back to the caller. The expression 5 plus 2 is evaluated to produce the result 7, which is then printed to the console via character output. 1 second. It's one of those times where just like I completely read it out loud so that it sounds okay, and then I'm like, I didn't register that. Hang on. Okay. It's like literally I'll say it out loud like what's happening, and then I'll read it. I'm like, what is it saying to me right now? I'm like, oh, that's exactly what I said. Never mind. In the third statement, function return 5 is called again, resulting in the value 5 being returned back to the caller. However, function main does nothing with the return value, so nothing further happens. The return value is ignored. Note, return values will not be printed unless the caller sends them to the console via character output. In the last case above, the return value is not sent to character output, so nothing is printed. Tip: when a function returns a value, the caller may decide to use that value in an expression or statement by using it to initialize a variable or sending it to character output, or ignore it by doing nothing else. If the caller ignores the return value, it is discarded. Nothing is done with it. There we go. Here we go. Fixing our challenge program. With this in mind, we can fix the program we presented at the top of the lesson. Okay. This function now returns an integer value. Return input. Return what this ended up being. Whatever the user inputted, please return that to main. And so then int num is then going to call the function. That's how it will apply it to num. Perfect. I love that. When this program executes, the first statement in main will create an int variable named num. When the program goes to initialize num, it will see that there is a function call to get value from user. So we'll go execute that function. Function get value from user asks the user to enter a value, and then it returns that value back to the caller main. This return value is used as the initialization value for variable num. Num can then be used as many times as needed within main. Tip: if you need to use the return value of a function, call more than once. Initialize a variable with the return value, and then use that variable as many times as needed. Initialize a variable with a return value, then use that variable as many times as needed. Okay, I think they're just saying you can use a function more than once. Like, I don't know what it's saying here really. If you need to use the return value of a function call more than once, initialize the variable with the return value, and then use that variable as many times as needed. Oh, instead of calling the function a bunch, make like this num variable and then call num a bunch, I think is what it's saying. I think that's what it means. Call the variable num rather than calling the function a bunch. Compile this program yourself and run it a few times to prove to yourself that it works. That's okay. I can see it. I can see it. Well, I guess we can, so we could get some of the, excuse me, some of the stuff in there, you know. Because if they're gonna ask me to write, I'd like some of the, what's it called? Keywords, you know. Enter an integer. 900. Whoa. It did it. Okay. Revisiting main. Uh-oh. I took a nap earlier. I didn't sleep well, so I'm like, I can go a bit later. Revisiting main. You now have the conceptual tools to understand how the main function actually works. When the program is executed, the operating system makes a function call to your main. The execution then jumps to the top of main. The statements in main are executed sequentially. Finally, main returns an integer value, usually 0, and your program terminates. In C++, there are two special requirements for main. Main is required to return an int. Explicit function calls to main are disallowed. Okay. It's like a keyword, right? Like you can't use that. Key insight. C does allow main to be called explicitly. So some C++ compilers will allow this for compatibility reasons. That's interesting. For now, you should also define your main function at the bottom of your code file, below other functions to avoid calling it explicitly. What? Okay, they're saying do your functions and then do your main, below other functions to avoid calling it explicitly. For advanced readers, it is a common misconception that main is always the first function that executes. Global variables are initialized prior to the execution of main. If the initializer for such a variable invokes a function, then that function will execute prior to main. We discussed global variables in lesson 7.4, Introduction to Global Variables. Status codes. You may be wondering why we return 0 from main and when we might return something else. I actually was a little bit like, okay, like why are we doing that? The return value from main is sometimes called a status code, or less commonly an exit code, or rarely a return code. The status code is used to signal whether your program was successful or not. By convention, a status code of 0 means the program ran normally, meaning the program executed and behaved as expected. Because all the way at the bottom, if we got a 0, it fully ran every line. Best practice, your main function should return the value of 0 if the program ran normally. A non-zero status code is often used to indicate some kind of failure. While this works fine on most operating systems, strictly speaking, it's not guaranteed to be portable. I'm pretty sure that is like a debugging thing, that it's like you just kind of, if there's like certain sections that you feel like are causing the problem, you'll put like the stop code, I guess, of not 0, maybe of like 2, I don't know. Somewhere around there to see if it like gets to there. And then, okay, it got to 2, so let's see if it gets to 3, or, you know, right? Some kind of, indicate some kind of failure. It's like it should get to 0, but it stopped at 3, you know, right? Is that how that would work? Strictly speaking, it's not guaranteed to be portable. For advanced readers, C++ standard only defines the meaning of 3 status codes: 0, exit success, and exit failure. 0 and exit success both mean the program executed successfully. Exit failure means the program did not execute successfully. Exit success and exit failure are preprocessor macros defined in the cstdlib header. Okay. If you want to maximize portability, you should only use 0 or exit success to indicate a successful termination, or exit failure to indicate an unsuccessful termination. We covered the preprocessor and preprocessor macros in lesson 2.10, Introduction to the Preprocessor. Yeah, why would you write that out? And you could just put a 0. It's just one character. As an aside, the status code is passed back to the operating system. The OS will typically make the status code available to whichever program is launched to the program returning the status code. The OS will typically make the status code available to whichever program launched. Hello? We're chickening. The OS will typically make the status code available to whichever program launched the program returning the status code. I don't know why that like is tripping me up, the words, but basically the Windows is going to tell whatever program, yeah, you got a 0, right? This provides a crude mechanism for any program launching another program to determine whether the launch program ran successfully or not. Is that why sometimes, sorry, this is silly. I'm like, is that why sometimes I like run a program, it ran fine, and then Windows is like, it seemed like it didn't run well. Do you want to like run it in compatibility mode? I'm like, it ran fine. So I'm assuming like didn't get a 0. And so it's like, whoa, I didn't get a 0. So was that good or what? Like, are you good? Is that what's happening? A value returning function that does not return a value will produce undefined behavior. Okay. Function that returns a value is called a value returning function. Function that is value returning if the return type is anything other than void. Okay, so all functions will return something unless you say void. Right? A value returning, so if you are telling a function you'll return a value and it doesn't return a value, the program is not going to run. Well, a value returning function must return a, sorry, I was rereading the top and now it's just repeating itself. Must return a value of that type using a return statement. Otherwise, undefined behavior will result. Related content. We discussed undefined behavior in 1.6. We did do that. Here's an example of a function that produces undefined behavior. All right, let's see. So character outputting. Okay, sorry. We have a function, initialized a function, get value from user UB. Character output, enter an integer. Input. There's no return statement. Okay. And so then we're asking it to return, to get what it returned. And it's like, but I didn't return anything because you didn't ask me to return anything. But I'm supposed to return something. You didn't say void. You said I'm supposed to get an integer and you didn't ask me to get it, right? Modern compilers should generate a warning because get value from user UB is defined as returning an int, but no return statement is provided. Running such a program would produce undefined behavior because get value from user UB is a value returning function that does not return a value. So it's like main called the function. I was like, hey, get value from user, and then get value from user answered, and then it was just like breathing on the line, like it didn't have any. It was like, I'm gonna hang up now, and then the program crashes. Sorry. A modern compiler should generate a warning. Did I already read this? Undefined behavior does not return a value. Most cases, compilers will detect if you've forgotten to return a value. However, in some complicated cases, the compiler may not be able to properly determine whether your function returns a value or not in all cases. She should not rely on this. Best practice. Make sure your functions with non-void return types return a value in all cases. Failure to return a value from a value returning function will cause undefined behavior. Right. Make sure anything that should return a value does return a value. Function main will implicitly return 0 if no return statement is provided. Okay, so program probably won't crash. Main is gonna hang up and they're gonna be like 0. There was nothing there. I don't know what that was. The only exception to the rule that a value returning function must return a value via a return statement is for function main. The function main will implicitly return the value 0 if no return statement is provided. That said, it is best practice to explicitly return a value from main, both to show your intent and for consistency with other functions, which will exhibit undefined behavior if return value is not specified. Functions can only return a single value. Okay. So you'll want to have many functions for like each little thing you need done. Or each value you'll need. A value returning function can only return a single value back to the caller each time it's called. Note that the value provided in a return statement doesn't need to be literal. It could be a result of any valid expression, including a variable or even a call to another function that returns a value. In the get value from user example above, we returned a variable input which held the number the user input. There are various ways to work around this limitation of functions only being able to return a single value, which we'll cover in future lessons. Okay. The function author can decide what the return value means. The meaning of a value returned by a function is determined by the function's author. Some functions use return values as status codes to indicate whether they succeeded or failed. Okay. Other functions return a calculated or selected value. Other functions return nothing. We'll see examples of these in the next lesson. Because of the wide variety of possibilities here, it is a good idea to document your function with a comment indicating what the return value means. For example, function asks user to enter a value. Return value is the integer entered by the user from the keyboard. Entered integer, input, character input, input. And then return what input is. Return the value the user entered back to the caller. Reusing functions. Now we can illustrate a good case for function reuse. Consider the following program. Enter an integer. Enter an integer. We did this one. Remember our little calculator? I think that's what we just deleted here. While this program works, it's a little redundant. In fact, this program violates one of the central tenets of good programming. Don't repeat yourself. Often abbreviated dry. Keep it dry. Why is repeated code bad? If we wanted to change the text, enter an integer. Sorry. If we wanted to change the text, enter an integer to something else, we'd have to update it in 2 locations. And what if we wanted to initialize 10 variables instead of 2? That would be a lot of redundant code, making our programs longer and harder to understand, and a lot of room for typos to creep in. Okay. Let's update this program to use our get value from user function that we developed above. Because we're developers, oh my god. All right. Get value from user. We are initializing our function. We're character outputting. Please get input and return that input to me. So. Okay. So then we're going to initialize x, and x is going to be calling this function. Y is going to be calling that function. And so then when we get to character output, it'll get to x. Like, it's literally going to get to x. And it's going to be like, wait, what's x? Okay, wait, what's get value from user? Oh, okay, I have to run this. Let me ask them to get an integer. So it's literally going to start basically with the output, but before it outputs, it's going to ask for an integer. Like it literally gets to the output, but then it's like, oh wait, enter an integer though? Like, hang on. Or maybe it calls it, or like runs it right here. So it'll ask it here, and then it'll okay, that's probably what it does actually. So that here it'll know what these are. Okay. Enter an integer, and then it'll ask it again. X, Y, X plus Y. This program produces the following output. In this program, we call getValueFromUser twice. Once to initialize variable X and once to initialize variable Y. That saves us from duplicating the code to get user input and reduces the odds of making a mistake. Once we know getValueFromUser works, we can call it as many times as we desire. This is the essence of modular programming. The ability to write a function, test it, ensure that it works, and know that we can reuse it as many times as we want, and it will continue to work, so long as we don't modify the function, at which point we'll have to retest it. Best practice, follow dry. Keep it simple, stupid. Don't repeat yourself. If you need to do something more than once, consider how to modify your code to remove as much redundancy as possible. Variables can be used to store the results of calculations that need to be used more than once, so we don't have to repeat the calculation. Functions can be used to define a sequence of statements we want to execute more than once. And loops, which we'll cover in a later chapter, can be used to execute a statement more than once. Like all best practices, dry is meant to be a guideline, not an absolute. Reader Yaruv has noted that dry can harm overall comprehension when code is broken into pieces that are too small. That makes sense, too. As an aside, the snarky opposite of dry is wet. Write everything twice. That's funny. I like that. Conclusion. Return values provide a way for functions to return a single value back to the function's caller. Functions provide a way to minimize redundancy in our programs. Quiz time. Inspect, do not compile, each of the following programs. Determine what the program will output or whether the program will generate a compile error. Assume you have to treat warnings as errors turned off. Okay, so like, even if it's messed up, it'll run. Just assume it'll run, even if it's broken. Okay. Return 7. So we're gonna say 7, 9, and then we're gonna character output 7 and 9. New line 0. So that looks correct to me. So it just should be 7 and 7 plus 9. Whoops. Duh. It's I'm like, it'll print 7 plus 9. Like, no. That's a evaluation happening here. So it'll print 16, which is 7 plus 9. Okay. 1B. Oh, this is gonna be broken because you can't have a function inside a function. But we're gonna say return 7 and 9, so it'll be like 79. Oh, no, this is so broke. Return 7 and return 9, so 7 will return 7 and 9. And 9 will just return 9. So, hang on. Math. 7, 9. 9. 25? That's broken? Yeah, I was like, I feel like it's too broke to even try. It's Program will not compile. Nested functions are not allowed. Yeah, I was like, it's illegal. I'm gonna call the cops. Return 7, return 9, return 7, return 9. So it's just literally gonna say 7, 9. I think like right next to each other even, because even though there's no white space, there's no new line. Oh, it doesn't, because it's just calling it. It's not even doing like character output. Damn it, quiz got us. The return values from the functions are not used for anything and thus are discarded. Main was like, what do you want me to do with that? Okay. All right, look, come on, let's get it together. Get numbers, 5 and 7. Character output, get numbers. Character output, get numbers. So we're gonna get 57, 57, right? Program prints 5 twice on separate lines. Both times when function get numbers is called, the return 5 statement executes, and the program returns. The return 7, I don't know if I ever picked that up from the lesson. The return 7 statement never executes. They probably said it and I just didn't register, but that makes sense. Once you get a return, it stops. So it'll get the return 5. And then it's like, oh, okay, cool. Throw that back and I'm done. Like, bet. Okay. Return 5. That doesn't look allowed. This is not right. This is wrong. That'll be a compile error for sure. Because you didn't write the function correctly. There should be no white space. The program will not compile because the function has an invalid name. We're talking about naming rules in lesson 1.7. Keywords and naming identifiers. What does dry stand for, and why is it useful practice to follow? Don't repeat yourself, because your code should be as like concise as possible. If you're repeating yourself, you're wasting your time, more room for errors. Yep. Dry stands for don't repeat yourself. It is a practice that involves writing your code in such a way so as to minimize redundancy. This makes your programs more concise, less error prone, and more maintainable. Excuse me. Okay. 2.3, void functions, non-returning functions, non-value returning functions. In a prior lesson, Introduction to Functions 2.1, we indicated that the syntax for a function definition looks like this. Return type identifier replaced with the name of your, why does it look like this? I do like when they do these, like, this is the return type, this is the identifier, a function looks like that with the parentheses. This is what a function looks like. Although we showed examples of functions that had return type void, we did not discuss what this meant. In this lesson, we'll explore functions with the return type of void. Void return values. Functions are not required to return a value back to the caller. To tell the compiler that a function does not return a value, a return type of void is used. For example, void print hi. Character output hi. This function does not return a value, so no return statement's needed. In the main, it's going to just run the program. It's going to print out hi, and it doesn't need to give anything back to main because it's already outputted hi. What else? What other information does this need? Let's just say hi. In the above example, the print hi function has a useful behavior. It prints hi, but it doesn't need to return anything back to the caller. Therefore, print hi is given a void return type. When main calls print hi, the code in print hi executes and hi is printed. At the end of print hi, control returns to main and the program proceeds. A function that does not return a value is called a non-value returning function, or a void function. Void functions don't need a return statement. A void function will automatically return to the caller at the end of the function. No return statement is required. A return statement with no return value can be used in a void function, such as a return statement with no return value can be used in a void function. Such a statement will cause the function to return to the caller at some point where the return statement is executed. This is the same thing that happens at the end of the function anyway. Consequently, putting an empty return statement at the end of a void function is redundant. Return. Tell compiler to return to the caller. This is redundant since the return will happen at the end of the function anyway. Function will return to caller here. This close bracket will do the return anyway, so don't even write it. Best practice. Do not put a return statement at the end of a non-value returning function. Void functions can't be used in expression that require a value. Some types of expression require values, for example. Okay. So we character output 5. And then we're telling it to character output nothing, and it don't like that. Some expressions require values. Yeah, character output, I need something. You can't just tell me to output nothing. In the above program, the value to be printed needs to be provided on the right side of the character output extraction. Right? Yeah, sorry. If no value is provided, the compiler will produce a syntax error. Since the second call to character output does not provide a value to be printed, this causes an error. Now consider the following. Print hi. Print hi. Character output print hi. Compile error. It likes print hi. It's okay. Print hi is called, no values returned. It says hi. It doesn't like this because we're saying character output, double character output. And it's like, why did you do that? Why are you doing this? Yes. First call to print hi is called in a context that does not require a value. I see. That's also, okay, that's what's happening. Character output wants a value. And then print hi is a function that will not give a value. It threw it away when it closed because it already outputted what it needed to. First call to print hi is called in a context that does not require a value. Since the function doesn't return a value, this is fine. The second function call to function print hi won't even compile. Function print hi has a void return type, meaning it doesn't return a value. However, this statement is trying to send the return value print hi to character output to be printed. Character output doesn't know how to handle this. What value would it output? Consequently, the compiler will flag this as an error. You'll need to comment out this line of code in order to make your code compile. Tip: some statements require values to be provided and others don't. When we have a statement that consists of just a function call, the first print hi in the above example, we're calling a function for its behavior, not its return value. In this case, we can call either a non-value returning function or we can call a value returning function and just ignore the return value. When we call a function in a context that requires a value must be provided. In such a context, we can only call value returning functions. Function that does not return a value, void, return nothing, do nothing. Function that returns a value, please return 5. When calling a function by itself, no value is required. because it's not even outputting it, nothing. Call a function that returns a value and ignore that return value. When calling a function in a context that requires a value like character output, okay, we can call a function that returns a value and the value will be used. Compile error. We can't call a function that returns void in this context. Correct. Returning a value from a void function is a compile error. Trying to return a value from a non-value returning function will result in a compilation error. Print hi. This function is non-value returning. Return 5. Compile error. We're trying to return a value. You got a void function, and then you're telling it to return something. It's like, what? Bitch. You said void, not int. That's an int, and this is a void. I'm supposed to return nothing. Quiz time. Question number 1. Inspect the following programs and state what they output, or whether they will not compile. Okay. We've got function print A, character output A. We have function print B, character output B. And then we got main, print A, print B. Okay. Quiz time. Yeah, that's him doing his little pop quiz. Oh my god. That is going to... I was about to say it was going to do nothing, but it will output A and B side by side, I believe. Because I was like, oh, it's just calling the functions, but because it's void, it's going to run that function, and so it's going to output when it runs the function. This program prints the letters A and B on separate lines. Oh, I said on the same line. Why? Oh, while I was rewatching the playlist and everything for C++, I want to clarify. I was saying when we were writing our code that we put the new line and we flushed it. We were flushing it with the new line, but it literally explained that end line is what flushes, but that you should not use end line, you should use new line because it doesn't flush. That C++ in general does automatic flushes, so you shouldn't be manually flushing anyways. Exactly. So I just wanted to clarify that. I was like, oh, we're not flushing information with new line. Duh. We're just making a new line. Okay, we're looking at this one now. Void. Okay, we're gonna character output A. This is not going to compile because character output print A is already character outputted, or it wants the character output A, but then it didn't return it. So it's like, I don't have the information you want. I can't return this. So you get no value, and then character output's like, what do you mean I don't get a value? What? Why? And he's like, because I'm void. And like, he's like, you're void? This program does not compile. Function print A returns void. He returns void, and he's like, you're void, which can't be sent to character output to be printed. This will produce a compile error. Okay. I was kind of feeling like we do that one and finish, but I'm like, how long is this one? You know, these are we're kind of schmoovin'. Fixing our challenge program. Oh, I like doing that. This one's a little bit long. Whoa, I'm scared. Hang on. In pictorial format. I don't know what we're talking about, so I'm scared, but like, I do like that. It's good for my visual learning. This is a big Ooh. Quiz time. Right? A complete program that reads an integer from the user, doubles it using the double number function you wrote in the previous quiz question, and then prints the doubled value out to the console. I said I wanted to get some coding in, so I'm like, maybe we just read really fast. Okay. That doesn't look like too much. Scrolling up, it didn't feel like too much. Scrolling down was kind of crazy. All right. Let's get in it. .4 Introduction to Function Parameters and Arguments. In the previous lesson, we learned that we could have a function return a value back to the function's caller.
Wait a minute. Who are you?
That's literally when character output's asking the function, but it's void. It's like, who are you? You're void. In the previous lesson, we learned that we could have a function return a value back to the function's caller. We used that to create a modular get value from user function that we used in this program. Get value from user, character output, enter an integer, input, return the input, double times 2. However, what if we wanted to put the output line into its own function as well? You might try something like this. Enter an integer. This function won't compile. Void. Print double. Character output. Num double is. Eesh. Yeah, because what's num even? You initialized it here. Hello? So it won't compile because function print double doesn't know what identifier num is. You might try defining num as a variable inside function print double. Void print double. In num, we added this line. Num doubled is num times 2. This addresses the compiler error, makes the program compilable. The program still won't. Yeah, I was like, there's like no way to like input that, like, because we got input, return input. Like, where is that even? Print double. Yeah, this isn't able to pull from over here, right? So we'll compile because function print double doesn't know what identifier num is. You might try defining num as a variable inside function print double. So work correctly, it always prints 0, doubled is 0. The core of the problem here is that function print double doesn't have a way to access the value the user entered. We need some way to pass the value of variable num to function print double so that print double can use that value in the function body. Function parameters and arguments. In many cases, it is useful to be able to pass information to a function being called, so that the function has data to work with. For example, if we wanted to write a function to add 2 numbers, we need some way to tell the function which 2 numbers to add when we call it. Otherwise, how would the function know what to add? We do that via function parameters and arguments. A function parameter is a variable used in the header of a function. Function parameters work almost identically to variables defined inside the function, but with one difference. They are initialized with a value provided by the caller of the function. Function parameters are defined in the function header by placing them in between the parentheses after the function name, with multiple parameters being separated by commas. Here are some examples of functions with different numbers of parameters. This function takes no parameters. It does not rely on the caller for anything. It's outputting in do print. Just do that. And it doesn't need nothing. Excuse me. This function takes one integer parameter named x. The caller will supply the value of x. Void print value. Oh. In x inside the function parameter. Sorry, this whole paragraph was one of those times again where I was just kind of reading it and not taking it in, but I was like, I'm sure I'll pick it up once I look here, and I'm like, oh, that's what we're talking about. Character output, what x is. And so this is relying on the functions like also main what's x, right? This function has two integer parameters, one named x and one named y. Caller will supply the value of both x and y. Int add, int x. This is another function, okay. Okay, this is the function add. And we're gonna have the parameters asking main, like what's x and what's y, right? Right? I'm confused a little. Or we're initializing them, right? Is that kind of what's happening? Maybe I should read this again. They are initialized with a value provided by the caller of the function. Okay. An argument is a value that is passed from the caller to the function when a function call is made. Do print. This call has no arguments. Print value 6. 6 is the argument passed to the function print value. Add 2, 3. 2 and 3 are the arguments passed to function add. Note that multiple arguments are also separated by commas. Interesting. How parameters and arguments work together. When a function is called, all the parameters of the function are created as variables, and the value of each of the arguments is copied into the matching parameter using copy initialization. This process is called pass by value. Function parameters that utilize pass by value are called value parameters. For example, this function has two integer parameters, one named x and one named y. The values of x and y are passed in by the caller. Okay. So we've so confused. When function print values is called with arguments 6 and 7, oh, okay. So in the main, we're calling the function and we're telling that function, can you put in 6 and 7 into your function, please? And then it's literally, I was like, what's happening?
He can't keep getting away with it.
So the function is given 6 and 7, and it's like, oh, you want x to be 6 and y to be 7? Got it. So I'll output 6 and 7 for you. And if we wanted to output other numbers, we could redo this function and put just different numbers. It'd be like, oh, bet, I'll do that instead. Okay, I get it now. Print values parameters. When function print values is called with arguments 6 and 7, print values parameter x is created and initialized with the value of 6, and print values parameter y is created and initialized with the value of y. This results in the output 6, 7. Note that the number of arguments must generally match the number of function parameters, or the compiler will throw error. That's what I was a little curious about. I'm like, I assume there's 1 comma, so if you're calling that function and inputting information, you need to have the same amount of like commas information. Match the number of function parameters, or the compiler will throw an error. The argument passed to a function can be any valid expression, as the argument is essentially just an initializer for the parameter, and initializers can be any valid expression. Fixing our challenge program. We now have the tool we need to fix the program we presented at the top of the lesson. So we're going to get value from user, character output, and then we have a void function. This function now has an integer parameter. So our parameter is that we have an integer value. So it's gonna be void because it's still doing an output. It's like you don't need to return anything to main, but it still needs information from main. So it's like, let me know what that is and I'll put it in here. And then main is like, bet that's gonna be, hang on, in num. We're gonna say num is gonna run this, so the input, whatever input returns will be num, and then print double num. So whatever num is, we're telling the print double function, hey, the value you want is whatever num is, which is what they inputted. And it's like, bet. I keep saying bet. Then that value is times 2. In this program, variable num is first initialized with the value entered by the user. Then function print double is called, and the value of argument num is copied into the value parameter of function print double. Function print double then uses the value of parameter value. Using return values as arguments. In the above problem, we can see that variable num is only used once to transport the return value of function getValue from user to the argument of the call to function print double. We can simplify the above example slightly as follows. Okay, so character input, get value from user. Print double, get value from user. So this function is to be, what's the value? And it's like, oh, the int is actually this int function. So that value you want is actually over here. If you could run that for me. And it's like, oh, fine. Then it runs that to get a returned input, which it then knows to put that input as the value. And then it'll run. Right. print double, McDoubles, coupons. Now we're using the return value of function get value from user directly as an argument to function print double. Although this program is more concise and makes it clear that the value read by the user will be used for nothing else, you may also find this compact syntax a bit hard to read.
Oh, shit. Here we go again.
If you're more comfortable sticking with the version that uses the variable instead, that's fine. Be honest, it is a bit simpler. This is a little like bloop, 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 bloop for like, can you just times it by 2, please? Like real quick. How parameters and return values work together. I can see like this is very good writing for something that will like be built up. There's like, I'm gonna need to pull this multiple times. But for this like one dinky calculator, it's better to write it the first way. But if you're wanting to build like an infrastructure of like a program, you'd want to do it this way. How parameters and return values work together. By using both parameters and a return value, we can create functions that take data as input, do some calculation with it, and return the value to the caller. Here's an example of a very simple function that adds 2 numbers together and returns the result to the caller. Add takes 2 integers as parameters and then returns the result of their sum. Oh. The values of x and y are determined by the function that calls as. I see now more why they're like, you don't need to learn all of C++. You don't need to learn like all of these words and shit. You need to learn like what's possible so that when you're then now trying to program, you know what to look up. So I'm like, oh, you can do an equation in a return. Oh. The values of x and y are determined by the function that calls add. Main takes no parameters. What? Saying add is form 5. So form 5 and it's going to return 4 plus 5. New arguments form 5 are passed to function add. Okay, so the answer should be 9. Execution starts at the top of main. When we add 4, 5 is evaluated, function add is called, with parameter x being initialized with the value 4 and parameter y being initialized with the value 5. The return statement in function add evaluates x to plus y to produce the value 9, which is then returned back to main. This value of 9 is then sent to character output to be printed on the console. Output 9. In pictorial format. Gotcha. Beep. Beep. Aha. Beep. And line. Who wrote this? Just kidding. More examples. Let's take a look at some more function calls. Okay. Adding it up, multiply. We can multiply them. We're going to ask the function to add together 4 and 5. We're going to ask it to add. Oh, snap. You're doing some PEMDAS shit. So we're going to ask and add. Can you do 1 and 2 as x and 3 times 4 as y, and then it's gonna be like, okay, so x is 3 and y is 12. So sounds like you get a 15. Sounds like a basketball. Okay. I can't unhear it now. Okay, give me a second. I'd be like, would you knock it off, you crazy kid? Okay. And so int a 5. What is a? Character output. I guess we've initialized variable a is 5. And so then we're asking add, hey, can you add together 5 plus 5? Evaluates 5 plus 5. So then it's going to be 5. So yeah, the answer would be 10. Character output 10. And then character output posture check. What's wrong with it? Got this. Oh my gosh. Oldie but a goodie. Okay. My heart had to soar with the eagle's nest. Add, so 1, oh my goodness, and then it's asked call in another function. So we're saying x is 1, but y is this function, which is 2 and 3. So x 2 and 3, so 6. So y is 6, and then 6 plus 1, so answer 7. This one's 7. Like I'm in math class, I'm sweating. Okay. And then with add, we also get 1. And then we're gonna run it again inside 2 and 3. 5, so then we're gonna do 5 plus 1 is 6. Program produces the output. 7, 6. Yeah, I think pretty sure we got all these. Yep. 5 plus 5 is 10. First statement is straightforward. In the second statement, the arguments are expressions that get evaluated before being passed. In this case, 1 plus 2 evaluates to 3, so 3 is copied to parameter x. 3 times 4 evaluates to 12, so 12 is copied to parameter y. Excuse me, I'm burping again. Add, okay, the function add 312 resolves to 15. The next pair of statements is relatively easy as well. In this case, add is called where the value of a is copied into both parameters x and y. Since a has a value 5, add a equals add 5, 5, which resolves to value 10. Let's take a look at this first tricky statement in the bunch. When the function add is executed, the program needs to determine what the values for parameters x and y are. X is simple since we just passed it the integer 1. To get a value for parameter y, it needs to evaluate multiply 2, 3 first. Program calls multiply and initializes z equals 2 and w equals 3. So multiply 2 and 3 returns the integer value 6. That return value of 6 can now be used to initialize the y parameter of the add function. Add 1, 6 returns integer 7, which is then passed to character output for printing. Put less verbally. Add 1 multiply 2, 3 evaluates to add 1, 6 evaluates to 7. Sure. Following statement looks tricky because one of the arguments given to add is another call to add. Yeah, I was like, well, hello. But this case works exactly the same as the prior case. Add 2, 3 resolves first, resulting in the return of 5. Now it can resolve add 1, 5, which evaluates to the value of 6, which is passed to character output for printing. Less verbosely, add 1, add 2, 3, evaluates to add 1, 5, evaluates to 6. Unreferenced parameters and unnamed parameters. In certain cases, you'll encounter functions that have parameters that are not used in the body of the function. These are called unreferenced parameters. As a trivial example, void do something, int count, warning, unreferenced parameter count, doesn't know what count is. This function used to do something with count, but it is not used any longer. Main do something for. So it's telling it like count is 4. And it's like, well, what do I do with this for? I don't know. Do something with it. Just like with unused local variables, your compiler will probably warn that variable count has been defined but not used. In a function definition, the name of a function parameter is optional. Therefore, in cases where a function parameter needs to exist but is not used in the body of the function, you can simply omit the name. Parameter without a name is called an unnamed parameter. Void do something int. Okay, unnamed parameter will not generate warning. The Google C++ style guide recommends using a comment to document what the unnamed parameter was. Oh. Okay, that's cute. She's cute. Author's note. You're probably wondering why we'd write a function that has parameters whose values isn't needed. Yeah, it was a little bit like Google's saying to do this, so like that's common, I guess. That's just fun. Why we'd write a function that has a parameter whose value isn't needed. This happens most often in cases similar to the following. Let's say we have a function with a single parameter. Later, the function is updated in some way, and the value of the parameter is no longer needed. Hydrate. Let's say we have a function with a single parameter. Later, the function is updated in some way, and the value of the parameter is no longer needed. If the now unused function parameter were simply removed, then every existing call to the function would break, because the function call would be supplying more arguments than the function could accept. This would require us to find every call to the function and remove the unneeded argument. This might be a lot of work and require a lot of retesting. It also might not even be possible in cases where we did not control the code calling the function. So instead we might leave the parameter as it is and just have it do nothing. For advanced readers, other cases where this occurs, operators ++ and -— have prefix and postfix variants. ++ foo versus foo ++. In unreferenced function parameters, this is used to differentiate whether an overload of such an operator is for the prefix or postfix case. I'll cover this in lesson 21.8. There's only 28 chapters. That's crazy. Overloading the increment and decrement decrement? What? Operators. When we need to determine something from the type rather than the value of a type of template parameter. What? Author's note. If unnamed parameters still don't make sense to you yet, don't worry. We'll encounter them again in future lessons when we have more context to explain when they are useful. That's good. Best practice. When a function parameter exists but is not used in the body of the function, do not give it a name. You can optionally put a name inside a comment. Conclusion. Function parameters and return values are the key mechanisms by which functions can be written in a usable way, as it allows us to write functions that can perform tasks and return retrieved or calculated results back to the caller without knowing what the specific inputs or outputs are ahead of time. Let's do it. Quiz time! got this. 11:11. All right, that only took us like 10 minutes, right? Ish. What's wrong with this program fragment? Let's see. Multiply. X, Y. Return X times Y. Character output. Multiply 4 and 5. What is wrong with it? Character. Oh. Wait. No, I don't have it yet. Hang on. Void. Oh, because it's a void and we're returning something. And character outputting. That's literally it. Hello, how are you doing? Morning. I'm like, I'm going to bed. Like, good morning. That's literally all it is. It's just that it's a void. It shouldn't be returning nothing. Right? Multiply has a return type of void, meaning it is a non-value returning function. Since the function is trying to return a value via a return statement, this function will produce a compile error. Return type should be int. Number 2. What 2 things are wrong with this program fragment? Of X and Y. Product. Okay, so that's creating a variable product. What the hell? That's the thing with like program that's like like written wrong is like what's wrong here. I'm like, what the hell is that? Like what is he even trying to do? Because I'm like, with the curly brackets, just, I'm like, I need to scroll up. I'm like, is there supposed to be white space? Yeah, this just feels wrong. Like, this looks... I don't know what's happening here. This is just wrong. I don't know what's happening. I know I don't like it. So we're going to character output the function. Oh, that's also... It wants 2 things, and we've only given it 1. Problem 1. Main passes 1 argument to multiply. Multiply requires 2 arguments. Problem 2. Multiply doesn't have a return statement. That's what's wrong. This felt wrong, though. Like, written wrong. I guess it's just, I don't know. But okay. It gets that multiplication, and then it doesn't give it back to me. So it's not even giving it the right information, and then it can't even give it back to it the wrong information. Question number 3. What value does the following program print? Okay, it's math time. Here we go. What? Math time? Okay, so we're gonna call multiply. First variable of multiply is 6, and it'll be times 4. Guys, what's 6 times 4? 24. Is that wrong? I failed my times tables, but I'm like, I don't care. We'll get this. I have calculators. So it should output 24. Multiply is called where x equals add 1, 2, 3, and y equals 4. First, the CPU resolves x, add 1, 2, 3, which returns 1 plus 2 plus 3, or x equals 6. Multiply 6 and 4, which is the which is the answer. 24 is the answer. All right. Got these two last. And then we're ready to go. Write a function called double number that takes one integer parameter. The function should return double the value of the parameter. Okay. And then number 5 is write a complete program that reads an integer from the user, doubles it using double number function you wrote in the previous quiz question, and then prints the doubled value out to the console. Okay. So, I'll get rid of these comments. We want okay. Start fresh. So we want it above our main. We're gonna, I like the void output system. I feel like it's clean to not be constantly returning data. So let's do void. We're gonna call it double number, right? Yep. See, I like doing my curly brackets like that, but they'd like it like that. I don't know. I don't know. Okay. So double number is going to have one integer parameter of x. And then it will character output it should literally just be x times 2. Got me again. Right. And then in main, we're gonna say well, okay. What the question 4 was to write a function called double number that takes one integer parameter. The function should return double the value of the parameter. So I think we wrote it. I think it's just that one line. We didn't return it. We didn't return it. Well, because I wanted to do the output. I wanted to do the void version. Oh, it should return. I'm not listening. Okay. Redo. We're going to return. No, we're going to int. We're going to int it. And then return it. Ay, ay, ay. So easy, so simple. So easy breezy. That is so clean. Ah! Come on. Okay. So we have our function. Correct. Now. Nope, we don't. This is an int. Whoopsies. Now it's happy. Okay. Does 2 times x or x times 2 really matter? I feel like it doesn't, but just in case. What am I doing? 2 times x, semicolon, colon. We're done. All right, now, write a complete program that reads an integer from the user, doubles it using the double number function you wrote in the previous quiz question, then prints the doubled value out to the console. Okay. So we're gonna say, give me a second, give me one moment. Okay. I got this. Int. We want to initialize, I guess, num. C. And then we want to, sorry, we're going to character output first. Enter an integer. It will initialize num, and then we'll do character input, num. And then we are going to character output shit, how do I write this? Hang on. Double number? Fellow. See? Hang on. And then this will be num. so that the function can get what was inputted. It'd be like bet times that by 2. It'll return the answer and then it'll output it, right? Let's see. 1 succeeded. 7. 14? Wow. All right, let's see the solution. Turn 2 times x. You know, sometimes I'm like, let me add the spaces. And it's like, no, there's no spaces. And then I'm like, no, it looks really clean without spaces. And it's like, no, you should separate it all. It's like, okay. Enter an integer. Ugh. They did x as well. You could just do x and x and x and x. I felt like that'd get confusing. For me, at least. I'd be like, what? X is what? No. You may come up with other similar solutions. There are often many ways to do the same thing in C++. Except... Oh, I didn't new line it! Son of a gun. So close. Although, hello, single quotes, they say don't do that. They said don't do that. Hello? Okay. Yeah, we did a perfect again? We did another perfect? That function, we did fuck up that function. But that's because I would have rather done the output in the function, but it was very specifically saying, please return, have the function return something. So I was not listening. But if I were listening, we probably would have gotten that perfectly fine. Because look at this. We did it again. Alright. We're going to end stream. Although I am going to do another typing real quick. That was so much fun. We did it. Next stream, probably for this, will probably be Saturday. And we will start up at 2.5, Introduction to Local Scope. So that feels very good. Like, we literally just covered, like, I think all of functions just now. Not all of it, but, like, the meat of it. That's really great. Oh, next lesson. I kind of want to do the same lesson to see, like, compare the time. You know, keep the control. Wasn't it? It was so good. It's function stream. All right, let's see. We're warmed up at all. We had 18 words per minute, correct? Okay. List. Engines. That was smooth. Ooh, oh, ooh. See, symbols are for sure my biggest weakness at this point. Info. For sure, faster. That got us last time. Ugh. Equal sign. No, please. Data. Engine. Info. Oh, it's just so much faster though. App. Sort. Engines on for each const. Sorry, it helps me to just say it out loud. No. Plugin info. Engines. M. Engines. I was trying to control myself from saying that. Ground control to Major Tom. Shoots on. From theme. Engine. Icon. Engine. Fuck. Kill me. Okay. Engine. Plug in name. M. Engines. Set. Current index to -1, please. Thank you. 22. That is a 4 word per minute increase over one stream. Excellent. All right. Let's figure out who we're rating out to. We did it. We did it. Went down for my nap and I was like, I don't know if we're gonna stream today, but I really wanna. What do we got? Ooh, hang on. We got a couple of choices. Uh-oh. I'm feeling front page. Oh my god, she's literally front page. Oh my god. Okay, well then we have to raid. Oh my god. That's actually crazy. One moment. She's playing a Resident Evil. A lovely Montana. She found her in Enigma's stream, I believe. And I'm like, my name is Montana. And so we constantly are like, oh hey, it's Montana. All right. But she's front page right now. She's VTubing. Resident Evil 1, a fave of mine. So, here's the raid message. Okay. Let's all congratulate her for front page. That's huge. From what I have seen, she's been like really working hard at streaming and building it up. Yeah. Let's go say hi. I'll be back tomorrow, more Lands of Lore. And then we'll be back with more coding Saturday. Very excited. We'll try to do longer than this, probably twice as long. And yeah, I'm gonna send you guys out. I always have a hard time ending streams. They're like voicemails. So I'm like, I don't know how to say goodbye. So, bye.